Welcome back to part 5 of our live training session here with our Whipple-charged S197 Mustang. In our last tutorial, we focused on dialing in our speed density table. So at this point, we know our airflow model has been sorted out 100% between the mass airflow and speed density. Now we need to turn our attention into working within the torque-based tables, making sure that all of the torque table references and anything that's referencing torque is going to be calibrated correctly, because that drives the drive-by-wire system, and the torque tables hinge upon being accurate based on airflows. Now that we know the airflow is right, we need to attack the torque tables. So we're going to be focusing just dealing with all of the torque tables and how to go about properly dialing them in this tutorial. Without further wait, let's jump in so we can check this out.
Welcome back to our live training session here with our Whipple-charged S197 Mustang. Now in this tutorial, we're going to be focusing on dialing in our torque tables. This process is relatively straightforward, but there are some specific things we need to know in order to accomplish getting our torque tables right. Now, we have an excellent starting point for our torque tables that we've used from the very first tutorial. So when we used the template applicator to bring in all the modifications and all the changes to our base file, the original file, we used torque tables in that template applicator file they provided that were from a supercharged application. So we have values in our torque tables that are populated between the driver demand and our main torque tables, so 0 to 14 and OP torque tables, that are reasonable starting points, actually probably 80, 90, 95% of the way dialed in already. Now we might have to do some fine tuning, and that's what we're going to be looking at here in this tutorial, how to fine tune our torque tables. We want to get rid of our IPC wheel torque error. We want to have it as close to 0 as possible. Anything less than 50 for an IPC wheel torque error is completely acceptable. But if we're between 50 to 100, that's something we probably want to clean up. And if we're higher than that, it's definitely going to be a problem. Now, the IPC wheel torque error is the plausibility check. It checks our torque-based system in our closed loop drive-by-wire throttle control, which is all torque-based, and make sure that the torque values that it's sourcing and running through the drive-by-wire control are going to be valid. They're going to be reasonable. They're not going to have any kind of discrepancies. If we're getting IPC wheel torque errors, that means that we have a problem in our torque-based control. That error could be in our driver demand table. That's the beginning of where we input a throttle input and we request a certain level of torque that goes then through a whole bunch of different tables within our speed density and our throttle body model to finally end up in our torque-based tables to essentially look up what the throttle angle, the actual throttle blade, should be at in order to reach that certain level of torque. So we might have an error in our driver demand table. We might have an error in our throttle body data. We used Whipple supplied data, so it should be relatively accurate. Or we could have an error in our torque table. We can actually solve our IPC wheel torque errors either by modifying our throttle body data tables, or modifying our driver demand tables, or modifying our torque and inverse tables. I like to go after the torque and inverse tables. That usually is the cleanest way to go about dialing things in. There's no right or wrong way getting your torque control or your throttle control system 100% accurate and getting your IPC wheel torque errors as close to 0 as possible, so that we don't go into a limp mode as we put our IPC wheel torque monitor value back to where it was stock or slightly above where it was stock, so we have that runaway throttle protection in place so we don't have any problems long-term as we start to drive our car. We want to make sure that we have things calibrated as best as possible. So that's what we're going to be focusing on in this tutorial. The first thing we're going to do is put ourselves into optimal power mode. We want to lock ourselves into a singular mapped point. Now that could be map point 0, or it could be optimal power. In this case, I'm going to lock myself into optimal power, and then we're going to go through and just do a quick drive in OP mode in our torque and inverse tables, just making sure that everything looks like it's in line, everything seems reasonable. We're going to monitor what's going on with our IPC wheel torque errors and see if we have areas that may need to be adjusted or touched up. This particular combination of parts, the big throttle body, the positive displacement supercharger, can get throttle surging, which is really annoying and something that we can generally compensate for and take care of when we're dealing with either dialing in either our throttle body data, trying to tweak and modify that, which I don't like to touch, or going after our torque tables, which is my preferred method for trying to eliminate throttle surge and those IPC wheel torque errors. We might be getting some of that throttle surging here. We'll have to see how that goes, try to dial that out using the method I'm going to show you here in this tutorial for dialing in the torque tables. Now, what I'm going to show you here in this tutorial varies slightly from what I've introduced in the main training course. So if you've watched the torque control tuning videos in the main training course, now you're going to be watching this tutorial, they're going to be varying slightly what we do. Now we can go about either method, but the method I'm going to show here when we already have our torque tables relatively close is what I prefer to go in and change. So basically what we're going to be doing here is overlaying our throttle angle error into our torque tables, what we're going to have in our histogram, and then we're going to use that as a guide to figure out where we're seeing our errors. So if we're seeing our IPC wheel torque errors or having throttle surging in a certain range of the table, we're going to be modifying our torque values and then being able to calculate the inverse. Now I'm not going to be using the inverse calculator here for HB tuners. I'm going to be using it from the spreadsheet. I've had mixed results using the inverse calculator lately in HB tuners. Not that there's anything wrong with it, but I just prefer to use the spreadsheet because it's a little bit more mathematically correct in terms of the values that it outputs. So we're gonna be going through that exercise, just dialing things in, making sure everything's 100%. Again,
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.